My dear friends, welcome to Rajshekar classes on applied data science with Python. This is lecture number 399. In this lecture, I will continue my discussion on constructing a decision tree. I request you to go through my previous lecture, that is lecture number 398, before understanding this lecture. All the points in my data set wherever the outlook is sunny, just see, wherever the outlook, this is outlook is sunny and humidity was normal, this is humidity, this is normal, and you are writing here yes. What does it mean? In that case, in which case outlook is sunny, humidity is normal, and my class label is yes. Just see, outlook is sunny, 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 sunny. But outlook is sunny and humidity is normal. What is your class label? Here you have yes. Here you have yes, isn't it? How did we construct this? How did we construct this decision tree? By using this decision tree is constructed using information gain as the criteria. So what are we literally doing at every stage in the decision tree? First we will start with the root. Actually here which one is root? Here root is outlook. We start with the root. We start with the root. Until that time you get pure node which has only positive class points or negative class points. You keep constructing it iteratively. You keep going further and further till the time you get pure node. Eventually, what will happen? Three things can happen. First one, you have a pure node, stop growing the tree. Second one, stop growing the tree means what? Just see this simple example, what it says. Here, this one is, what is this? Yes, just 1 second, what it says. If you have pure node, what it says, if you have a pure node, stop growing the tree. What you have to do? You have to stop growing the tree. For example, this is pure node. Why? Because 3 negative, 0 positive means here only you have negative points. I stopped it. Here 2 positive, 0 negative means only positive points. In that case, I must stop. That is the procedure. What it says, if you have a pure node, stop growing the tree. That is first one. Your second option is you can't grow the tree anymore because you don't have enough points. This is important. I will repeat. Second option is you can't grow the tree anymore because you don't have enough points. Because what is the reason here? You don't have enough points. Don't have enough points. Don't have enough points, or I can say a lack of points. It is you have to stop growing the tree because lack of points. Imagine what is third condition. My third condition is if you are too deep, stop growing the tree. Before understanding third point, we will try to understand second point. Imagine you have a decision tree. Let me assume this is your decision tree. This one is your decision tree. Suppose you have one positive point. Here you have one positive point and one negative point. Of course, if you break it, what happens? Just see, if you break it, what happens? If you break it, eventually you will get one positive and one negative point. Just see, you are getting one positive point and one negative point. You can't grow any further because there is only one point. Here this is pure node, one positive point, one negative point. Of course, remember, if you have only one point here, one positive point, one negative point, and the tree depth is very far, then what are you doing? See, there is only one point at bottom at leaf node. If you say there is only one positive point, what happens? Only one positive point. Whenever somebody, just what happens? Whenever if I If this condition is satisfied, I will come here. If this condition is satisfied, I will come here. If this condition is satisfied, I will come. This is the path. This first condition, second condition, third condition, fourth. This is the path. What happens in that case? Whenever somebody comes with this path, whenever somebody comes with this path, with this path, I will declare this point to be positive. I will declare this point to be positive point, isn't it? I will declare this point to be positive class point. That's actually dangerous. This one is actually dangerous. Why it is dangerous? Actually dangerous. In your whole training data, if there is only one point, there is only literally one point which follows through this path. There is only one point which follows through this path. All these conditions are satisfied. This condition is satisfied. This condition is satisfied. This condition is satisfied. With one point, if you have just one point, if the point is noisy, just one point, and another one is this. If assume this point is noisy point. If this point is noisy, what happens? This is useless. Oftentimes, what we do here is we say that we won't grow a tree, we won't grow a node. You cannot grow a node further if we have very few points. Here, what happens? We have only 2 points, very few points. Oftentimes, I can say like this. Yes, let me erase this one first. Yes, oftentimes we won't grow a node. We won't grow a node further if we have very few points. Here I have only 2 points. Yes, isn't it? We won't grow a tree, we won't grow a node further if you have very few points. So we can say at this stage. At which stage? At this stage. At this stage, you have 2 points, and I don't want to grow it any further. I don't want to grow it any further, isn't it? It makes no sense. It makes no sense. Imagine my data set has 10,000 points. Let me say I have a points 10,000 points. Let me say my data set has 10,000 points. I can keep growing my tree long and long. I can make extremely nested tree. Eventually, if I reach a node, what is this? Let me say like this. Anyway, we completed this case. You can't grow the tree. When you can't grow the tree, we won't grow the node further if you have very few points. Let's try to understand third case. If you are too deep, stop growing. For example, just say this one. Imagine my data set. What is my data set size? My data set size is 10,000 points. Let it be. This is 10,000 points. Isn't it? I can keep growing my tree long and long. I can make extremely nested tree. This is extremely nested tree, isn't it? It's extremely nested tree. Eventually, if I reach a node like this, what happens? How many if else conditions? 1 if else, 2 if else, 3 if else. I have 4 if else conditions, isn't it? 1, 2, 3. Even if I speak strictly, 5 if else conditions, isn't it? Yes. If there are only 2 points, here, isn't it? Only 2 points. Total data set is very large. Total data set is 10,000. If I have only 2 points, here, I don't want to give class label because I have only 2 points, isn't it? If I choose this path, only 2 points are satisfying this condition. If these 2 points are noisy, that is important. If these two points are noisy points, isn't it? If these 2 points are noisy points, then it is overfitting. Isn't it? What happens is we often stop growing the tree. If you get a pure node, that is first case. If there are if there are few points at node, if there are few points at node, and if we are too deep, just see, this is too deep, this is too deep. If we are too deep, we stop growing further. That's what it says. These are the three typical cases whenever we stop growing, when we stop growing the tree. And this example is very important. Imagine if I am growing the tree with very deep, and at this stage, let's assume at this stage, let me assume my total points is 10,000 points. My training data size is 10,000 points. If there are only 2 points here, just see here, if there are only 2 points here, what happens, which means my whole data set is 10,000. Let's assume both these points are positive. What we are saying here, I have 2 points. Let me assume these 2 points are positive. These 2 points are positive. If I go too deep, there are too few points. I could be overfitting. These 2 points are noisy points. If these 2 points are noisy points, I am using noisy points to decide my class label. It is extremely dangerous, isn't it? Think about it. As depth of the tree increases, just see, what can I say? As depth is increasing, what's happening? As depth of the tree increases, your chances of overfitting will increase. Why does the overfitting to noise increase? Because there are going to be fewer and fewer points at those nodes, and if the fewer points are noisy points, just see, here you have fewer and fewer points, 2 points out of 10,000 points, and if the fewer points are noisy points, if these points are noisy points, after growing the tree too deeper and you are getting too noisy points, then it is easy to overfit, isn't it? Then it is easy to overfit. As the depth increases, you are going to overfit. If the depth is, just see, as that's what it says, as depth increases, you are going to overfit. If depth is very small, what happens? If depth is very small, then it's going to be underfit, isn't it? In decision tree, the big hyperparameter is the depth of the tree. And how do you find right depth? You can use standard techniques like cross validation. Use cross validation. What is the best depth of the tree? It means cross validation can be used to find best depth of the tree, because your depth of the tree is similar to lambda in logistic regression, which controls overfit and underfit or bias and variance trade-off. Similarly, like C is a hyperparameter in SVM, support vector missions. Depth plays the same role. If you get a pure node, you will stop. But if you don't want to go deep, how do you decide the right depth? The right depth can be calculated using cross validation. Anyway, I will discuss about this overfitting and underfitting in my next lecture also. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.